So we've done some work at the University of York, where we've actually been growing plants in small tubes. We've been using Arabidopsis. We've been dosing it with platinum group metals, looking at the uptake. We've subjected the material to a stabilization process, which what we've really been doing is carbonizing the material. So we essentially form a kind of palladium on carbon material, and then we can use these in applications. So what we've done is we've shown that the plants take up the metals and actually form nanoparticles in situ. We also see these nanoparticles are retained when we make a carbonized material, and we can use them for a range of different reactions. In this case, we've been doing some cross-coupling reactions, some Suzuki reactions, and they work very, very well. This is actually a paper that we recently published. It's open access, so feel free to download it and read about this in more detail. We have looked at reuse of the catalyst because we want to try and use the catalyst more than once to give it added benefit. And we've shown that we're able to use the catalyst around four times without a significant loss in activity. However, after the fourth use, what we see is the distribution of nanoparticles. We end up getting much larger, bigger nanoparticles formed. And why is this? Well, in actual fact, what's happening is in the reaction, some of the palladium is coming off the support. It's doing the reaction in a kind of quasi-homogeneous state. And then what happens is it redeposits back on the support. So it redeposits back on, but it forms larger nanoparticles, which are less active. But at the end of four uses, we can burn off the plant material and recover our palladium as well. So we've shown that we can use this in with a large range of different substrates as well, and it's a very effective method of actually developing catalysts by using this natural process that plants do on a daily basis. We've gone one step further, and we've gone from these little plants in these little pots to larger pot trials. So this is moving from Arabidopsis to willow. And we've shown the same thing. We get nanoparticles forming in the plants. And we've also shown successful catalysis as well. We now have field trials going on in Australia and New Zealand, and pot trials going on in York. So it's quite a large project, and it's working out very, very nicely. But we think we're just kind of scraping the surface of this kind of technology. And in actual fact, this is a review that we published recently where we actually show that you can use this technology for a whole range of different elements and also a whole range of different applications. So from a green perspective, there's a lot that we can do with this phytoremediation or phytoextraction technology.